Okay, 4-3. You would think we'd be getting into something brand new, but nope. Still factoring polynomials, but these are unique ones. These are ones that if you just notice, like, hey, this is a special kind, you can take a little shortcut and just factor them just like that. As you can see, I've got written up on the board here. One of them is called difference of two squares. Another one's called perfect square trinomials. Now we go back to my old thing. If you're on a test and it's timed, like an ACT, SAT, college entry exam, you don't want to just get the right answer. You want to get the right answer quickly. So that's why I like to give students a little trick or two on situations like this. So here's your pre-lesson. So I'll get to that in a minute. But let's say this was the math problem. And maybe you can already see where I'm going with this. This is actually asking us to multiply because we got a set of parentheses right next to each other. So we're going to go first, outside, inside, and then last. And now look what happens. These cancel. And we end up with x squared minus 49. So let's say the instructions said factor. And the problem was x squared minus 49. Well, look at the name. It's a difference, which means subtraction, of two squares. What does that mean? Well, perfect squares. In other words, if I was to take the square root of x squared, I'd get x. If I got the square root of 49, I'd get 7. If this was a 48, I don't get a perfect square. And this little technique wouldn't work. But if you notice it's a difference of two squares, you can already kind of look. You just make a set of parentheses. One's a plus, one's a minus. You take the square root of the first term, put it in the first spot. You take the square root of the second term, put it in the second spot. And yes, you can change the order as long as one of them's a minus and one of them's a plus. Okay? Now I'm going to throw this little curveball at you, though. I think I can get it on here. A lot of students think that you can do the same thing with the sum of two squares. But this is not factorable. If you tried to go x plus 7 and x plus 7 and you FOIL that out, you're going to get 14x in between them. Trust me. If you tried to say x minus 7, x plus 7, now you got a problem because you got negative 49. We need a positive 49. This is not factorable. Nothing will work. I throw that in, no charge. Okay. So now, perfect square trinomial. Well, here's the thing. If I was to FOIL this out, I'd go x times x is x squared, plus x, plus 1. I get x squared plus 2x plus 1. Now, that's if the instructions were to multiply. What if I have this as my problem and it said factor it? Now, you guys might be saying, well, that's just a not a one, and it's super easy. You're right. Whoops, did I say not a one? I meant got a one. Bad me. That means this is a 1. What that means is I can go right to my parentheses, look at this last term, and say, what two factors of 1 add up to 2? Well, I know this is x and this is x, and this would have to be plus 1 and plus 1. And you might think, well, that's not a trick. You're not saving me much time. Well, it would be if, let me show you, the problem in your packet is 121 s squared minus 66 st plus 9t squared. All right, so on that one, and I'm not going to finish it. I'm going to finish it in the packet. But are you really thinking that you're going to treat this as a not a 1 and multiply this by this and get some ginormous number to figure out two factors of that add up to negative 66? There's got to be a better way. What's jumping out at me is this is a perfect square root and this is a perfect square root. What does that mean? It means there's a very, very good chance there's a shortcut. And I'll show that to you when we get to our packet lesson. Boom. Boom.